Hi students, welcome to today's class. Today also I am going to explain previous year's JEE mains questions from the chapter Differential Equations. Okay, so without wasting your valuable time, so I am straight away going to the subject. Okay, so my videos are very important. So in each and every video, each and every class, I am explaining the short trick method. So don't skip my videos. Okay, so let us start our class. Let the solution curve y is equal to y of x of the differential equation 4 plus x square into dy minus 2x of x square plus 3y plus 4 dx is equal to 0 passes through the origin, then y of 2 is equal to. So here this is an integer type of question. Let us see the problem. So here it is given. So this is the differential equation. Now we have to get it in the either a variable separable form or homogeneous form or linear differential equation form. Let us see that. Then what we will do? First I will take minus 2x to that side. So this is equal to 4 plus x square into dy is equal to 2x into x square plus 3y plus 4 into dx. Okay. We want dy by dx. Take this dy by dx to one side. 4 plus x square into dy by dx is equal to. So this I will write down like this. I will write this. So this is a 2x into. So this is equal to x square plus 4 plus. So this is 2x x square plus 4 plus this is a 2x into 3y. This is a 6xy. 6xy I can write that. And take this 6y to this side like that. 4 plus x square into dy by dx. So here I have taken dx to this side. I have multiplied 2x into x square plus 4, 2x into 3y, 6xy. Take this 6xy to left hand side minus 6xy, 2x into x square plus 4. Now I will divide each term with 4 plus x square. Now what happens? This is a dy by dx minus 6x by 4 plus x square into y. This is equal to 2x. Why? Because here x square plus 4, x square will plus 4 will get cancelled. So it is a clearly a linear differential equation. So this is a function of x. This is also a function of x. Very clear. Now what is the integrating factor? So integrating factor is equal to e to the power of minus 6x upon 4 plus x square. So here you have to take very carefully. So 4 plus x square derivative is how much? 2x. In the numerator I will write it like this. So of course integral dx you have to write down e to the power of minus 6. Now so this is I will write down like this, e to the power of minus 3 integral of 2x by 4 plus x square dx. Can I write it as? Yes, I can write. Why? Because 4 plus x square derivative is 2x. I have creating 2x in the numerator. Since minus cx is there, I have taken minus 3 outside. Okay, right. So this is equal to e power minus 3 ln of 4 plus x square. Okay, now. So this is equal to e to the power of ln of 4 plus x square whole power minus 3. 4 plus x square. So this is a ln of 4 plus x square whole power minus 3. On the whole, what is our integrating factor? 1 by 4 plus x square whole cube. So why? Because here e and ln will get cancelled. Okay. So on the whole, your integrating factor we got, that is 1 by 4 plus x square whole cube. What is the general solution? Since it is a y, differential equation y, so y into general solution, y into integrating factor, y into 4 plus x square whole cube is equal to integral of, so this term, that is equal to 2x by 4 plus x square whole cube dx. Understand this? Very nice problem. So if you observe here, 1 plus x square derivative is 2x only, it is in the numerator. So what will be its integral? So this is a 4 plus x square whole power minus 3 plus 1 by minus 3 plus 1 plus c. This is a 4 plus x square whole cube. Okay now? Very nice. So to find this constant of integration, so here one hint is given, the curve passes through the origin. Origin means what? 0 comma 0. So wherever x is there 0, put substitute 0, y is there, substitute 0. See what happens. So this is 0 by 4 plus 0, on the whole this is 0 is equal to, this is 0, 4 plus 0, 4, 4 power minus 2, 4 power minus 2 by minus 2 plus c. So this value is equal to how much? 0 is equal to 1 by 4 square, 16. Already 2 is there, 32, minus 32, minus 1 by 32 plus c. Therefore, c is equal to 1 by 32 we got. So the constant of integration is 1 by 32. So this c value is 1 by 32, right. Now the problem is over. Now y of 2 is asking y of 2. That means when x value is 2, what is the y value? So x value is 2, substitute here, 2 square 4, 4 plus 4, 16, 16 cube, 16 into 4 plus 4, 8, 8 cube, 8 into 8 into 8, multiply. Here also put x is equal to 2, substitute, and everywhere you substitute, wherever x is there substitute. When x is equal to 2, you will get y is equal to 12. So 12 is your right answer. 12 is, so try to calculate this here, wherever x is there, substitute 2, you will get y value is equal to 12. Okay now? So very, very nice problem this is, okay. I hope that you understand this solution. So let us go for next problem. Welcome to the second problem. See so this is one of the variety problem. So far we did not get this type of problem. So let us see very carefully. Very, very easy problem this is. Let y is equal to yn of x, y is equal to y2 of x be two distinct solutions of the differential equation dy by dx is equal to x plus y with y1 of 0 is equal to 0, y2 of 0 is equal to 1 respectively. Then the number of points of intersection of these two curves, that is y is equal to y1 of x and y is equal to y2 of x. First let us solve. There are two curves are there. Both are for both the curves this is the solution. Be two distinct solutions. For this differential equation, these two curves are solutions. First let us take this curve differential equation, that is dy by dx. So take this y2 left hand side, that is equal to minus y is equal to x. So this is a very clear, this is a differential equation in the variable y. So here minus 1 is the function of x. So what is the integrating factor? Integrating factor is equal to e power integral of minus 1 dx, that is e power minus x. E power minus x is the integrating factor of the given differential equation. Now what is the general solution? Now it is y is there. So y into e power minus x is equal to integral of whatever may be here. So that is a x into integral factor dx. Okay. So this is a clearly a by parts formula. So we know the result, highlight that type of. So first take outside x, e power minus x integral, e power minus x, again minus x derivative minus 1 minus integral of x derivative is 1. So e power minus x integral is, so this is e power minus x by minus x dx. Okay now, right. So now this is again, so this is a minus x into e power minus x plus, so e power minus x, again you will get minus plus c. So this is a y into e power minus x. So this is e power minus x, e power minus x, e power minus x. So better multiply with e power x so that the equation will be somewhat clear. So that's why multiply with e power x, that is I am multiplying with e power x. Let us see what happens. This is a y is equal to minus x minus 1 plus c into e power x. Okay. So, y is equal to minus x minus 1 plus c into e power x. So, that the equation will be somewhat better comparatively previous one. Now, here the real problem starts. To find the constant of integrations, here we have two distinct solutions. Let us take first case 1. What is the first solution? Y is equal to y1 of x. For this is what is given? y1 of 0 is equal to 0. So, if x is equal to 0, y is also 0. Substitute wherever x is 0, x is 0, y is 0. So, this is also minus 0, minus 1 plus c into e power 0. Okay, now e power 0 is 1. So, this is a minus 1. So, this implies c is equal to 1. Now, what is the solution for this? So, this is y is equal to minus x minus 1 plus c value is 1 e power x. Okay, now. So, you have to call it as y1. y1 actually speaking, this is a y1 you have to call it as. So, this is call it as first equation number 1. Again case 2 you take case 2. What is case 2? That is for y is equal to y2 of x. What is given? y2 of 0 is equal to 1. Wherever x is equal to 0, y is equal to 1. X value 0, y value 1. So, this is equal to 1 is equal to minus 0 minus 0 minus 1 plus c into e power 0. E power 0. So, take e power 0 is 1, take minus 1 to this side. This implies c is equal to 2. C is equal to 2. Now, your equation will become y is equal to minus x minus 1 plus 2 into e power x. Call it as second equation. Okay, now if you want to find out the point of intersection of these two curves, we have to solve these two equations. Okay, so let us solve these two equations. Welcome back. So, these are the two curves. So, here left hand side quantities are y, therefore, we can equate the right hand side quantities. That is minus x minus 1 plus e power x is equal to minus x minus 1 plus 2 e power x. Okay, so minus x will cancel, minus 1 minus 6 will be cancel. So, here e power x is equal to 2 times e power x. So, if you take that means e power x, if you take to that side 2 e power x minus e power x, that is e power x is equal to 0. Ultimately what you get? E power x is equal to 0. So, how many solutions are there? That means how many x values are there so that e power x is equal to 0. So, that means no values, no solutions. Why? Because if you observe, this is a y is equal to e power x curve, this is y is equal to 0 line. Y is equal to 0 is the x axis, y is equal to e power x. So, it is intersect the y axis at x is equal to 0, 0 comma 1. It never touches the x axis, okay. So, these two curves, they doesn't touch at anywhere, okay. So, you can't find any value such that any x value such that e power x is equal to 0. Therefore, the number of solutions are 0. Okay, na? Right. Very, very nice problem this is. I hope that you understand this solution. Let us go for next problem. Welcome to third problem. So, here the third problem is, let the slope of the tangent to the curve y is equal to f of x at x comma y be given by 2 tan x of cos x minus y. If the curve passes through pi by 4 comma 0, then the value of integral of 0 to pi by 2 y dx is equal to. So, the problem is a very, very direct problem. So, nothing any difficult words or difficult terms or difficult concept is there. The only thing is slope of the tangent. Whenever slope, the term slope appears, immediately you have to think that this is dy by dx. The slope of the curve, that is dy by dx, is given by the formula. It is given that 2 tan x into cos x minus y. Then you change it into either in the linear differential equation or homogeneous or variable and separable method. So, first you multiply inside, dy by dx is equal to, if you multiply inside, what happens? tan x means sin x by cos x, 1 cos x will cancel. So, this is a 2 sin x minus, so you multiply 2 tan x into y. Okay. Bring this minus 2 tan x to right hand side, left hand side, sorry. So, this is a dy by dx plus 2 tan x into y is equal to 2 sin x. So, it is a clearly a linear differential equation. So, this will be your to be integrating factor. So, this is our integrating factor is equal to e power integral of 2 tan x dx, that is e power 2 into integral of tan x is means how much? So, ln of secant x. So, this is equal to 2 will come here, e and ln will get cancelled. So, this is equal to secant square x. Understand this? Now, what is your general solution? So, y into this integrating factor, that is secant square x is equal to integral of whatever may be this value, that is equal to 2 sin x into secant square x dx. Okay, now if you observe secant square x, that means secant x into secant x, one secant x put it as a 1 by cos x, sin x by cos x, tan x. On the whole, this is nothing but I will write it as y into secant square x is equal to 2 times, so this is a secant x into tan x dx. Okay, 2 times integral of 2, so 2 I have taken outside, so this is a secant x into tan x, 1 by secant x cos x, sin x by cos x, tan x. Now, what is the integral of secant x into tan x? We have to find out the constant of integration. See, to find the constant of integration, one hint is given, that is pi by 4 comma 0. So, wherever x is there, substitute pi by 4 and y is 0. So, this will become 0, 2 into secant pi by 4 plus c, that is equal to 0 into secant pi by 4. So, cos pi by 4 is 1 by root 2, this is a root 2 plus c, c is equal to minus 2 root 2. Constant of integration c is equal to how much? Minus 2 root 2. Okay. We will put constant of integration here minus 2 root 2 and we will find out the integral of 0 to pi by 2 y dx. Okay. So, let us continue our solution. So, this is our solution, the slope of the solution it is given. So, here we have to find out integral 0 to pi by 2 y dx. We want y value. So, here secant square x is there. That is why take 2 secant square x on the right hand side. That is why for that divide with secant square x on both sides. So, this is a y is equal to 2 by 2 secant x by secant square x. 1 secant x will get cancelled, 2 cos x minus 2 root 2 cos square x. Why? Because by secant square x becomes 1. Now, integrating 0 to pi by 2 y dx. So, this is equal to integral 0 to pi by 2 y dx. This is 2 into 0 to pi by 2 cos x dx minus 2 root 2 integral 0 to pi by 2 cos square x dx. Okay, now. So, very nice problem this is. So, this is equal to 2 into cos x integral, this is a sin x. So, this is a upper limit and lower limit minus 2 root 2 into 0 to pi by 2 cos square x. I can write it as a 1 plus cos 2x upon 2 dx. Okay, now. So, this is a upper limit and lower limit you substitute. This is equal to sin pi by 2, it is 1 minus 0, this is 1. Okay, now. So, minus 2 root 2 into, so if you take this 2 will get cancelled. So, we will put root 2. For 1 it is x plus cos 2x integral. So, this is a sin 2x, again 2x derivative again. So, this is a pi by 2 to 0. Okay, now. So, you substitute these values and in place of x substitute pi by 2 here, next you substitute 0. If you substitute here pi by 2, so again we will 0, here you will get pi by 2. So, 2 minus root 2. So, you will get this is a 2 minus root 2 pi by 2 you will get. This is 2 minus pi by root 2. So, option B will be your right answer. See here I am checking. So, I am substituting here pi by 2. If you substitute here pi by 2, 2 will get cancelled, sin pi 0. So, upper limit only you will get pi by 2, lower limit anyhow you will get 0. So on the whole, this value is pi by 2. So root 2 into pi by 2, that is pi by root 2. So option 2 will be the correct answer. Okay now. So very, very easy problem this is. So only twist is, so you have to find out this integral. Okay now. Right. I hope that you understand this solution. Let us go for next problem. Dear students, welcome to this fourth problem. The fourth problem is, if x is equal to x of y is the solution of the differential equation y into dx upon dy is equal to 2x plus y cube into y plus 1 into e power y, where x of 1 is equal to 0, then x of e is equal to, so the options are given. Okay. Let us see the first this differential equation. Okay, this is a so far we have got dy by dx type of differential equations. Now we are going to see the dx by dy type of differential equation. So first time what I am going to do is divide with y on both sides. That is a dx by dy is equal to, this is a 2 by y x. So here y, so this is a y square into y plus 1 into e power y. Okay now. Take 2 by y into x this side. So this is a dx by dy minus 2 by y into x is equal to y square into y plus 1 into e power y. So this is a linear differential equation in x. So this is completely a function of y. This is also a function of y. So what is the integrating factor? So your integrating factor is equal to e to the power of integral of minus 2 by y dy. E to the power of integral of minus 2 by y dy. So this is equal to e power minus 2 into ln y. Okay. So minus 2 will come, y power minus 2, this is equal to 1 by y square. Okay. So that is integrating factor. So what is the general solution? See here, what is there here? Top x, x into that. That is x by y square is equal to integral of whatever may be this here, one integral factor into complete this term. So that is equal to y square into y plus 1 into e power y dy. Here y square will get cancelled. See here, by seeing this you can easily tell the one formula is there. What is the formula? Integral of e power x into f of x plus f dash of x dx is equal to e power x f of x plus c. So here e power x is there, y derivative is 1, y derivative is 1, that's why. So this is equal to e power y into y plus c. So this is a x by y square. So your x by y square, so again I am writing here x by y square is equal to y into e power y plus c. To find the constant of integration, one hint is given. What is that? X of 1 is equal to 0. So be careful that this value is y and this value is x. This is y value and this x value, reverse order. Y is equal to 1, x is equal to 0. So this whole becomes 0. 1 into e to the power of 1 plus c. Therefore, c is equal to, if you e power, that is minus e. C is equal to how much? Minus c. So wherever c is there, substitute here. X by y square is equal to y into e power b. C value is minus c. Nice, very nice. Now we have to find out x of e. X of e means what? Y value is e. Y value is e. Wherever y is there, substitute e. So this is equal to x by e square is equal to e into e to the power of e minus e. Check. Now multiply, cross multiply, this is a x is equal to, this is e square into, this is a e into e cube minus e. So you can take again this e cube will come here also, e cube will come. Now you can take e cube. So here e power e, sorry, here e power e is there, e power e is also there, here e cube minus e cube. Again take e cube outside, this is e power e minus 1. So e cube into e power e minus 1, option 1 will be the right answer. Very easy problem. This is a linear differential equation in x. integrating factor, general solution, c value we got minus c, I have substituted, and x of e is equal to wherever y value is e, I have find out x value. Answer is a very easy one. So, such a easy problems are also asking in JEE mains examination. So, I hope that you understand this solution. Dear students, I hope that you enjoyed today's class with a new chapter, that is straight lines. So, I am going to geometry part. So far I have explained about limits, continuity, differentiability, and definite integration, indefinite integration, and the differential equation. Calculus part I have discussed. In the tomorrow onwards, we are going to switch on to geometry part. So, the first chapter I am going to take is straight lines. Okay. So, let us start the straight line chapter tomorrow. Until then, all the best.